In this video, we want to add some more features to our exercise and mainly look into turning on the bookkeeping layers, which means that we want to look more detail inside the available materials inside the bed of the channel. So what happens below the bed of the channel? This is the main goal of this exercise. To do that, we want to start with the exercise 1B, dig a trench of 1 meter deep with 1 kilometer length there. Still run a morphological model with the morphological factor of 250. So in this figure down here, you can see the side view of our new model. So a trench inside the bed. And if we look at the top view, this is the place that we want to dig for 1 meter. Of course, I will show you how to do this in Quicken. But then to turn on the bookkeeping, we need to add some files in our more file. So we have a more file that the GUI of Delft 3D has generated for us. We need to look into that and add some lines to this. This will turn on the bookkeeping layer. So using this first line under layer 2, we turn on the bookkeeping layer. We will tell the model that we have the maximum number of layers of 20. The transport layer or the active layer is 0.5 meter thick, and all the bookkeeping layers are also 0.5 meter thick. So we will introduce these numbers in our more file. Also, we can add some more lines to have more output from the model. You can see this here. So we can ask the model to write DM, so the mean dimension for us in the output file, and also the D50, D10, and D90 of the materials, which covers the top section of the bed of the canal. So we are also asked the model to make these type of outputs and write them in the output files of Delft 3D. To do all these changes, we of course need to start from the GUI, but before doing that, I will make another directory in my working directory, and I will call it case 2A. So it's a new case that we want to make. And as I mentioned, the base of this case 2A is our case 1B. So I go there and select all the files that I need for this new model. So excluding the outputs of the previous simulation, I make a copy of them in my new directory. So now I have this directory that I can start working with. I minimize this. I now select the working directory again because now I have a new directory. That directory is case 2A. And then I choose this as my working directory. Now I can go to Grid, Quicken, and import my grid and depth. I want to dig a canal somewhere here. Yeah, it really doesn't matter where, but it is good to have a bit of distance from the boundaries. So I zoom a bit, I edit polygon, new polygon. I choose 10 grids. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I dig a canal. I choose this polygon, and then I want to dig a canal here. So it is done by adding 1 meter of depth to all these depth points which fall inside this polygon. So I come here and say, okay, combine depth with uniform value, add uniform value to depth, and then I say, okay, add the 1 meter depth to all these values. And now you can see that I have a trench in the middle of my flume or my canal which I previously modeled. Now I need to export. The grid is exactly the same as previously, but the depth is different. So I change the depth to case 2. So I call the name of the depth case 2 and I save it. I have this new depth. So I have done the first part of the change, which was about digging a trench inside this flume. I can close this. Now I can return to flow and then open my flow input. I open the case 1B and I say that, okay, now this case 1B is changed to case 2A, just to have a description correct. Everything is the same except the fact that my bathymetry is now not case 1 depth, but it is case 2 depth. And just to be sure, I can go to visualization and look at it, and you can see, okay, now the trench is in the model. If you remember from the exercise presentation, another thing that I needed to change was the sediment availability of the second fraction of the sediment, which was the finer sediment. I go to physical parameters, sediment, and the sediment 1 is still 400 micrometer and 5 meter, and sediment 2 is 100 micrometer, but I will change it to 5. And I will go and save file, save all. Also, the domain was correct. The rest of the thing that I need are similar to case 1B. But as you remember, I mentioned that there are things that I need to change in the more file. What is the more file? More file is one of the files that is used in the Delft3 simulation, and you can find it here. So if you open this in a text editor, you can see everything which is inside this file. These are all the parameters that we had put in the GUI. But these parameters that now we want to put in the file are not possible to use the GUI for them. So I need to type them here. But to make life easy, I have already given you a add more file in the files that can help. And all these lines that I mentioned to you in the presentation are here. So I can easily copy all of them and paste them down here. Yeah. And when I close this, I save this, and now in the case 2A, I have this new more file as well. So what did I do? I changed the bathymetry in Quicken. I opened the flow inside the GUI of Delft 3D and changed the bathymetry there. And I changed some lines inside the more file. Yeah. One of the things that I did not do, I did not change the name of my MDF file. So it is good if I change this also to model 2A, just not to be confused later. Okay, so now I have it as 2A. So now everything is ready, and hopefully I will be able to run the simulation. I say start, and I say browse, and then I choose the case 2A, and then run it. You can say now that it is running. It's pretty quick, but comparing to the first models, it's a bit longer because now also we have bookkeeping layers. So if this model ends without error, we can look into the results and see how we can look into these bookkeeping layers that we add through quick plots. Okay, now this is finished and we can go and look into the results. I can open the file. It is case 2A, and I open the map file. So first, let's look at the morphological changes and bed level in water level points. So I come here and look at the bed level in water level points, but I want to look at one cross section again in the middle of the flume, in the middle of the canal. So I click this and keep the 6 there. And then for bed level in water level points, I want to look at time 1. So time step 1 at the beginning of the simulation. If I look at this, you can see that our trench is now completely visible there. Yeah, that was a trench that we had. But now if I look at the end of this, so if I say 49 here, and I change the color to, for example, purple, okay, add to plot, we can see that at the end of the simulation, this canal is completely full. Of course, I can also add the water level to have the scales a bit better. I add also the water level into this system, add to plot. And now, so initially we had this black line with the trench, and at the end you can see that the trench is fully filled in with sediment, filled up with sediment. And of course, the morphological changes of the end also is still there. But one of the important questions now to answer is what type of sediment filled this trench? So I close this, and again I look at the bed level in water level point, if I can find it again. Bed level in water level point, I change it black and I put it at time 1. Quick view. And this is, okay, what you saw. But now, if I look here, I have another new output here, which is sediment volume fraction. If I click on this, you can see that the K is now turned on. So we can also see that there is 22 different layers inside the bed. Yeah. So I go here and then change the continuous shade to patches with line, change the line just to purple to have a better visibility, and say add to plot. So you can see here now, this is the sediment fraction for sediment number 1 that we chose here. And at the initial condition, all the layers, bookkeeping layers inside the bed have 50% of this coarse sediment. So sediment fraction number 1. Remember that we put two different sediments, sediment 1, which was coarser, and sediment 2, which was finer, each with 5 meters in the model. And we can see that it doesn't mean that those 5 meters are on top of each other, but it means that we have in total 10 meter of homogeneously mixed sediments with 50% from the coarse sediment and 50% from the fine sediment. Yeah. Just for the fun of it, I also put the water level again on top because that will give us a better scale to see the things. Okay, so water level is also up there in 4 meter. And now, if I move from this time 1 to the end, so I choose all with changes with time here. And I choose this and go to the end. You can see that now the trench is full. Yeah, this was the place that we had the trench. But the sediment that has gone inside the trench and filled the trench is only about 30 to 35% coarse sediment. So it shows that the sediment that falls initially in the trench and start filling the trench up is fine sediment. If we want to see that, we can by choosing the sediment fraction again. So sediment, sediment volume fraction. Instead of sediment 1, I choose sediment 2 at the end, so 49, and I use the patches and again color of purple. Okay, if I say quick view, now we see that inside the trench, which was here, we have up to 70% of the sediment fraction number 2, which is fine sediment. So with doing these type of simulations and keeping the bookkeeping layer on inside the bed of a canal or a coastal zone or river, we can see what has happened inside the bed. which materials have moved from where to where. Maybe it's also good to see one of these two as an animation. So I close this. I check here to make sure that in all my data sets, there the time is already included in this graph. So yes, for water level, sediment, volume fraction, and bed level, I have the time. So now I can maximize this and start the animation using this button. I click here and then I don't want an output, but I will put it on a loop and I continue. And now you hopefully can see how things moves. So you can see that the sediment comes in. We are looking at the coarser sediment, so you can see that this blue one is the sediment that has the least amount of coarse sediment, about 20% to 30%. So you can see that first the sediment, the fine sediment drops here, or the mixture with the more fine sediment drops here, and when it is full, the trench is full, then the sediment on top of it is more or less similar to the initial sediment that we have. Okay, I hope that you have enjoyed this lecture and can do the assignments. Of course, if you have any questions, please find me and ask the questions from me.